Welcome back, everyone. Today we're doing a deep dive into something I think you'll find really fascinating.
Uh-huh.
Liquid neural networks, or LNNs for short.
Okay.
And, given your background in computer science, I know you're always super interested in kind
Yeah.
of the cutting edge of AI. So I
Absolutely.
think this is right up your alley.
Yeah, very cool.
So LNNs, they're kind of pushing the boundaries of what we think of as a neural network.
Okay.
Because instead of being static, like the traditional neural networks that we're used to,
Right.
these systems adapt in real time.
Wow.
And they draw inspiration from the way biological neurons work.
Interesting.
So very, very different.
Yeah. So not just processing data in a fixed way,
Right.
but actually changing and evolving as new information comes in.
Exactly. Like that's the power of LNNs.
Yeah.
That's what makes them so intriguing.
Yeah, that's super cool. I mean, that sounds pretty revolutionary.
Yeah.
Where did this all begin? I mean, was there kind of a single aha moment that led to this whole field?
So the foundational research can be traced back to
Okay.
MIT's Computer Science and Artificial Intelligence Laboratory.
Ah, MIT, of course.
So CSL.
Right.
And this was around 2020.
Okay.
And Reem Hosseini and his team,
Okay.
they were really the pioneers in this area.
Makes sense.
And they were looking at, how biological neurons function.
Uh-huh.
And, they're constantly adjusting to new inputs. And they thought,
Yeah.
why can't we build AI that does the same?
That's fascinating.
Yeah.
So that's where the liquid part comes in.
Yeah.
It's about mimicking that fluidity
Exactly.
of our own brains.
Yeah. And I can imagine as someone who, spends a lot of time coding,
Yeah.
trying to replicate that
Yeah.
has got to be incredibly complex.
Absolutely.
Yeah.
How do they actually pull that off?
So it all comes down to how LNNs actually process information.
Okay.
So traditional neural networks, right, they kind of analyze data in these discrete chunks.
Right.
But LNNs use what's called time continuous processing. So they're constantly analyzing data as it unfolds
Okay.
in real time.
Interesting.
So it makes them very responsive to changes.
Yeah, I'm starting to get the picture.
Yeah.
But how does this actually translate into real-world advantages?
Right.
I mean, where do they really shine compared to, the kind of traditional neural networks
Right.
that I'm used to working with?
So one key area is efficiency.
Okay.
And when we say efficiency, we're talking about, traditional networks
Uh-huh.
can be huge.
Mm-hmm.
They require a lot of computing power.
Right. Tons of resources.
But LNNs are remarkably compact.
Wow.
They can run on devices as small as a Raspberry Pi.
Really?
So that opens up a whole world of possibilities.
Yeah, especially as we move towards more edge computing
Yes,
and
yes.
AI on smaller devices.
Because that's a game changer.
It is, and I know from my own experience,
Right.
trying to optimize code
Mhm.
for limited resources is always a challenge.
For sure.
But beyond efficiency, what other benefits do LNNs bring to the table? Well, one of the things that's always bothered me about traditional AI is
Yeah.
this whole black box problem.
Right.
It can be so difficult to understand
Yeah.
how a network reaches a decision.
Right. It makes it really hard to trust these systems,
Totally, and especially
in like safety critical situations.
Absolutely.
Yeah. So how do LNNs approach this differently?
Well, because they're smaller
Okay.
and they tend to focus on the essential elements of a task.
Uh-huh.
They offer a much greater degree of transparency, so you can actually trace the reasoning behind their actions.
So you can actually see why they made a certain decision.
Yeah, exactly.
Oh, that's fantastic.
It makes them much easier to understand and crucially
Yeah.
to debug.
That's music to my ears.
Right.
Being able to pinpoint, where an LNN went wrong instead of
Yeah.
being totally lost in this maze of nodes and connections.
Exactly.
Yeah, this transparency. I mean, it could be a game changer,
Yep.
especially for someone like you who's, deep in the world of coding and development.
Yeah, for sure. I mean, think about it. You're developing a self-driving car
Okay.
with an LNN. You could potentially see exactly how the system is responding to different road conditions and make adjustments as needed.
So you have this level of insight that you just don't get
Exactly.
with the black box.
It's just not possible with traditional models.
Right.
That's one of the areas where LNNs really have the potential to shine.
It sounds like they could really be a major step forward in making AI more
Yeah,
reliable and understandable.
absolutely.
But I'm sure there are challenges too, right?
Of course.
I mean, no technology is perfect.
LNNs are still a developing field,
Uh-huh.
and there are definitely some limitations that we need to consider.
Okay, like what?
Well, one of the biggest hurdles right now is the type of data they require.
Okay.
LNNs, they really thrive on time series data.
Hmm.
Like, sensor readings or videos, they're not as effective when you're working with static data.
So like images or text.
Exactly.
That's interesting because a lot of the data sets that I work with
Uh-huh.
are kind of a mix of different data types.
Right.
So it sounds like LNNs might not be like a one-size-fits-all solution.
Right.
But I wonder, are there ways to maybe combine the strengths of LNNs with other approaches?
That's a really interesting question, and actually researchers are already exploring that ways to create these hybrid systems
Okay.
that leverage the dynamic adaptability of LNNs
Uh-huh.
along with, say, the pattern recognition capabilities of other architectures.
So you could have a system that uses like convolutional neural networks to, extract features
Yeah.
from images
Right.
and then feeds that information into an LNN for real-time decision-making.
That's the idea.
Sounds like you'd be combining
Yeah.
the best of both worlds.
Exactly.
That's really cool.
And it's not just about combining existing architectures. I think the principles behind LNNs could actually inspire
So?
entirely new AI models.
Wow.
We're really just scratching the surface
Mhm.
of what's possible with this liquid approach to computation.
I mean, that's what I love about computer science.
Uh-huh.
There's always this new frontier to explore.
Absolutely.
It sounds like LNNs are just the beginning of
Yeah.
a major shift in the way we think about and design AI.
Absolutely. A fundamental shift.
Yeah.
If we want to create truly intelligent machines,
Uh-huh.
we need to move away from these rigid, predefined models
Okay.
and really embrace that fluidity and adaptability
Yeah.
that characterize biological intelligence.
That makes a lot of sense.
Yeah.
I mean, this deep dive has really opened my eyes to the potential of LNNs.
I'm glad to hear it.
But before we wrap up, I want to go back to something you mentioned earlier about the limitations.
Okay.
You said that one of the biggest challenges is their reliance on time series data.
Right.
Could you expand on that a bit more?
Sure. So LNNs are designed to process data that unfolds over time,
Okay.
like a video feed or a stream of sensor readings.
Okay.
This allows them to capture that dynamic nature of the information
Uh-huh.
and adapt their responses accordingly.
Right.
However, this also means that they're not well suited
Okay.
for tasks that involve static data, like image classification
Okay.
or natural language processing.
So, for example, if I were building a system to recognize different types of objects in a still image,
Right.
an LNN wouldn't be the best choice.
Exactly. In that case, a convolutional neural network, or CNN, would be a much more appropriate choice
Okay.
because CNNs are specifically designed for image analysis.
Got it.
LNNs excel in scenarios where the data is constantly changing and the system needs to adapt in real time.
So it's all about choosing the right tool for the job.
Exactly.
But even though LNNs have this limitation with static data, I'm still really intrigued by their potential. You mentioned earlier that they could inspire the development of entirely new AI models. What kind of possibilities do you envision?
Well, one area that's particularly exciting to me is the development of AI systems
Okay.
that can learn and adapt in a more continuous and dynamic way.
So we're talking about AI that's not just processing information, but actually evolving its internal structure over time.
It's a radical departure from traditional AI,
Wow.
which relies on these fixed models that are trained on static data sets.
Yeah.
With an LNN-inspired approach,
Uh-huh.
we could create AI systems that are more flexible,
Okay.
more robust, and ultimately more intelligent.
That's a powerful thought.
It is.
I'm suddenly picturing a future where AI systems are not just tools, but partners that can learn and grow alongside us.
That's the end.
It's a future that's full of possibilities.
Absolutely.
And while there are certainly challenges to overcome,
Of course.
it sounds like LNNs represent a major step in the right direction.
I believe so.
This has been really eye-opening.
Good. I'm glad.
But, putting aside all this amazing potential for the future,
Yeah.
let's bring it back down to earth for a second.
Okay.
What advice would you give to someone like me,
Uh-huh.
a computer scientist
Right.
who's intrigued by this technology
Uh-huh.
and wants to, start exploring it?
I think the most important thing is to just stay curious and keep experimenting.
Okay.
Don't be afraid to try new things
Oh,
and see how LNNs can be applied to different problems.
so it's not just about waiting for the perfect LNN to appear.
Right.
It's about getting our hands dirty and seeing
Yeah.
what we can create with what we have now.
Absolutely. And as you experiment, remember to leverage those computer science skills.
Okay.
Think about how you can optimize, LNN architectures, develop new training algorithms, or even design entirely new types of neural networks inspired by the principles of liquid computation.
So using our existing knowledge as a foundation and building from there.
Exactly.
What areas of computer science do you think are going to be most relevant for someone working with LNNs?
Well, a strong understanding of algorithms and data structures is essential.
Okay.
You'll also need to be comfortable with concepts like differential equations and dynamical systems. These are really fundamental to how LNNs work.
Okay.
And of course, experience with machine learning and deep learning will be really invaluable.
It sounds like working with LNNs requires a really unique blend of skills.
It does.
Combining the theoretical with the practical.
Absolutely.
Are there any resources or communities that you would recommend for someone looking to kind of dive deeper into this field?
Absolutely. There are a ton of great online courses and tutorials that can give you a good introduction to LNNs.
And what about the research community? Are there any?
Yeah, the research community is incredibly active. There are tons of papers and conferences dedicated to LNNs.
Right.
I would definitely recommend checking out websites like ArcSiv and GitHub to stay up to date on all the latest developments.
That's really helpful.
Yeah, I hope so.
This deep dive has honestly been so eye-opening for me.
Good.
I'm really starting to see the potential of liquid neural networks. Not just as this, cool new technology, but as a catalyst for a whole new wave of innovation in AI.
And that's really what it's all about. I think LNNs, they aren't just another, incremental improvement in AI. They represent a fundamental shift in how we think about intelligence.
Right.
Moving away from those static models and towards systems that are dynamic, adaptable, and ultimately more aligned with the way we as humans learn and interact with the world.
It's been an incredible journey.
It has.
And I really want to thank you for sharing your expertise with me today.
It's been a pleasure.
I have a feeling we're going to be hearing a lot more about liquid neural networks in the years to come.
For sure.
And I'm really excited to see how they shape the future of AI.
Me too.
And really the future of our world.
It's an exciting time to be working in this field.
It is.
And, the future of AI is really in the hands of those who dare to imagine and create.
That's a great note to end on.
It is.
So to everyone listening out there, keep exploring, keep learning, and keep pushing the boundaries.
Couldn't have said it better myself.
Of what's possible with AI.
Awesome.